some problems on particular integrals and complementary functions. Now I'm taking one problem from set if d is equal to d by dx, d is equal to d by dx, then 1 by 1 plus d square of x square minus x, this is x square minus x plus 2 value is. As we know that there is a differentiable operator, that is d by dx. So we have to find the particular integral. This is nothing but. So this is equal to, I am taking 1 plus, it is in the form of 1 plus d square. So we can take into numerator 1 plus d square whole power minus 1. That is x square minus x plus 2 as this. So we can expand 1 plus x whole power minus 1 formula. So we get 1 minus d square. No need to take other terms. Here x square minus x plus 2. And multiply with here x square minus x plus 2. So we get x square minus x plus 2 minus d square means 2 times differentiation. 1 time differentiation is 2x minus 1. Again differentiation we get to 2. So here 2 will be cancelled. This is equal to x square minus x is the answer of the problem. Now I am taking another problem from set is also from set. The solution of the differential equation d square y by dx square plus 4 into y is equal to secant square, sin square x. This is sin square x please. Now we have to find the particular complementary function as well as particular integral. First I am writing the operator form d square plus 4 into y is equal to sin square x. So sin square x can be written as 1 minus cos 2x by 2 here. In place of sin square x I am writing 1 minus cos 2x by 2. First I am taking the auxiliary equation m square plus 4 is equal to 0. That is m is equal to plus or minus 2i. Therefore, the complementary function yc is equal to c1 cos x plus c2 sin x. This is the complementary function. Now we go for particular integral yp is equal to 1 divided by d square plus 4 of sin square x is equal to, we have 1 minus cos 2x by 2. So we can write this as 1 by 2 of 1 by d square plus 4 of 1 minus cos 2x. Just I am writing 1 by 2 outside of the bracket. So here 1 by 2 of, here for 1 we can apply particular integral individually. So we can write 1 by d square plus 4 of 1 minus 1 by d square plus 4 into cos 2x. So this is equal to, we can write 1 by 2 of, here we have constant, so constant term by constant term, therefore minus, when we taking d square is equal to minus a square, that is minus 4, here a equal to 2. So the denominator is 0. When the denominator is 0, we can take x in the numerator and differentiate the denominator. So d square differentiation is 2d into cos 2x as this. Okay. Now this is equal to, we can write 1 by 2 of 1 by 4 minus x by 2. 1 by d means integration of cos 2x. Integration of cos 2x is sin 2x by 2. So this is equal to 1 by 8 minus x by 8 sin 2x. This is the particular integral of the given differential equation. And the general solution is, therefore the general solution is y is equal to yc plus yp. Yc is c1 cos x cos 2x plus c2 sin 2x plus 1 by 8 minus x by 8 into sin 2x is the general solution. Now I am taking another set problem. Another set problem. The particular integral of y fourth derivative, y dash 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 plus 3y double dash is equal to 108 x square is. Now we need to find only particular integral, that is yp. So yp is equal to, we can write 1 by d power 4 fourth derivative plus 3 into second derivative d square, 108 x square. So this is equal to, we can take 3d square as common in the denominator. So we have d square by 3 plus 1. Here 108 x square. So we can write this as 1 by 3d square 1 plus d square by 3 whole to the power of minus 1, 108 into x. So we can write here, we can 3 will be cancelled. 3 3s are 3 6. So here we have 36 by d square. 36 by d square. We can expand by taking 1 plus x whole power minus 1 formula. That is 1 minus d square by 3. Here we have x square term only. Now multiply with x square, that is equal to 36 by d square. Here first term x square minus 1 by 3. D square means 2 times differentiation of x square. One time differentiation is 2x. Another differentiation, again differentiating, will get to 2. So this is equal to 36 divided by, here we have d square. D square means 2 times, 1 by d square means 2 times integration. First time integration x cube by 3 minus 2x by 3. Now again again integrate, will get to x to the power of 4 by here 12 minus 2x cube by 9. Okay. So this is equal to
2x square, sir, not x cube.
Yes, okay. This is 2x square by, it is 6. So here 36, here LCM is 12, that is x power 4 minus 4x square. Here it is 4 times or 3 times. This is equal to 3x power 4 minus 12x square. This is the particular integral of the given differential equation. Okay. Now I am taking another problem. It is from set. It is also set problem. The boundary value problem. Set the boundary value problem value problem. D square y by dx square plus y is equal to 0. Y of 0 is equal to 1, comma, y dash of 5 is equal to 5. As we have options here. First option A, a solution y is equal to c1 cos x plus c2 sin x, where c1 comma c2 are arbitrary constants. Okay, this is the option A. And option B, no solution. Option B, no solution. And option C, a unique solution. Y is equal to cos x plus 5 sin x. And D option, a solution y is equal to c1 e power x plus c2 e power minus x, c1 e to the power of x plus c2 e power minus x, where c1 comma c2 are arbitrary constants. Okay. Now first we have to find the solution of the given equation. That is, it is homogeneous equation. So we have to find only complementary function. That is, first I am taking auxiliary equation m square plus 1 is equal to 0. That is, m is equal to plus or minus I. Therefore, the general solution y is the complementary function below. So this is equal to c1 cos x plus c2 sin x. Now y is equal to c1 cos x plus c2 sin x means y of x is equal to this value. Y of x is equal to c1 cos x plus c2 sin x. Now they differentiate with respect to x. We get to y dash of x, that is equal to minus c1 sin x plus c2 cos x. Now apply the boundary condition. I am taking this as equation number 1. Now first boundary condition, y of 0 equal to 1, and the second boundary condition, y dash of 5 equal to 5. First I am applying first boundary condition, y of 0 is equal to 1. Then here we can substitute x equal to 0 and equating to 1. So c1 cos 0 1 plus c2 sin 0 is 0, that is equal to 1. Means c1 is equal to 0. Now we'll get c1 value there. C1 is equal to 1. So now apply the second boundary condition, y dash of pi is equal to 5. So apply in this condition. I am taking this as equation number 2. So while applying y dash of x is equal to minus c1 value is 1, that is 1 into sin 0. This is 0, completely 0, plus c2 into cos pi. Cos pi is minus 1, that is equal to 5. So from this we can write c2 is equal to minus 5. c1 is equal to 1 and c2 is equal to minus 5. Therefore, apply in the first equation. Therefore, y of x is equal to, that is cos x minus pi sin x. Now this is the unique solution. We are eliminated the arbitrary constant C1, C2. Okay. So option, okay, option C is, I think it is minus. This is minus. So option C is the right option. Okay. Now I'm taking another problem from gate. The solution this is the gate problem. The solution to the initial value problem. To the initial value problem. D square y by dx square. D square y by dx square plus 2 into dy by dx plus 5 into y is equal to 3 into e to the power of minus x into sin x comma y of 0 is equal to 0 and d by dx of y of 0 is equal to 3 is. First we have to find the complementary function as well as particular integral, then general solution and apply the boundary conditions. First time consider the auxiliary equation, that is m square plus 2m plus 5 is equal to 0. So we can resolve this as minus 2 plus or minus under root of b square minus 4ac by 2e. That is 4 minus 4 into 1 into 5 divided by 2 into 1. So this is equal to minus 2 plus or minus, this is 20, nothing but 4i. Minus root 16, that is 4i by 2. This is equal to, we can write 1 plus or minus 2i. These are the complex roots. Therefore, we can write the particular complementary function as yc is equal to e to the power of minus x into c1 cos 2x plus c2 sin 2x. This is the complementary function. Now we can find the particular integral. That is yp is equal to 1 divided by we have d square plus 2d plus 5. That is d square plus 2d plus 5 of 3 e to the power of minus x into sin x. 3 e to the power of minus x into sin x. Okay. So first of all, we have to replace d by d minus a. Here d by d plus a is equal to minus 1. So d minus 1. Now we get here 3 e to the power of minus x divided by d minus 1 whole square plus 2 into d minus 1 plus 5. Here sin x as this. So we can write this as e to the 3 into e to the power of minus x divided by, now a minus b whole square formula. Now that is d square minus 2d plus 1 plus 2d minus 2 plus 5. Here sin x as this. Here 2d will be x. So this is equal to 3 e to the power of minus x divided by, here d square is equal to, we can write to minus 1. So I am writing here minus 1. Here we have plus 1 minus 2 plus 5 into sin x. So this is equal to this is 1 will be cancelled, minus 2 plus 5, it is 3, this 3 and this 3 will be cancelled. So this is equal to e to the power of minus x into sin x is the particular integral. Now we can write the general solution, that is y is equal to e to the power of minus x into c1 cos 2x plus c2 sin 2x plus e to the power of minus x into sin x. This is the y of x value. Let it be some equation number 1. Now we go for a y dash of x. So y dash of x is equal to, here we can use UV method, e to the power of minus x constant u. This is minus 2c1 sin 2x plus 2c2 cos 2x. U b dash is completed. Then minus e power minus x derivative minus e power minus x. This is u dash. C1 cos 2x plus C2 sin 2x as this. Okay. And second term derivative. Again UV formula, e power minus x into sin x derivative cos x plus sin x into minus e power minus x. This is a y dash of x equation number 2. Now apply the boundary conditions here. First boundary condition, y of 0 is equal to 0. That means x is equal to 0 and y is equal to 0. So here in this we get c1 cos 0. Cos 0 is 1 plus c2 sin 0 is 0 plus e power minus e power 0 is 0, sin 0 is 0. This is completely 0 is equal to 0. So C1 value is 0. C1 is equal to 0. Now we have to find C2 value. C2 value కంటే ముందు ఇందులో y dash of x రాసుకుందాం. Therefore y dash of x is equal to e to the power of minus x into C1 0 చేసేస్తున్నా. అప్పుడు 2C2 cos 2x ఉంటుంది minus e power minus x C1 0 అయితే ఇక్కడ C2 sin 2x ఉంటుంది. రిమైనింగ్ ఇవి అలానే ఉంటాయి. e power minus x into cos x plus sin x into e to the power of minus x. Now apply the second boundary condition, that is y dash dy by dx of 0 is equal to 3. This is the second boundary condition. That means y dash of 0 is equal to 3. So replace x by 0 and y by 3. Y dash by 3. So we get here 3 is equal to this term 2c2 minus this term is 0 plus this term is 1 and this term is 0. So here we have 2 is equal to 2c2, that is c2 is equal to 1. Now c2 is equal to 1 and c1 equal to 0, substitute in equation number 1. So we get therefore the general solution y is equal to e power minus x into c1 value 0, that is 0, complete c1 cos 2x 0, c2 value is sin 2x, that is sin 2x plus e power x into e power minus x into sin x. Okay, this is the general solution of the given differential equation. Okay, now these are the problems related to differential equations, linear differential equations with order n with constant coefficients. Okay, now I'm taking another important method called it as method of variation of parameters. Method of variation of parameters. Okay. Now this is one method. This method is used when the complementary function is known or it is easy to find, and the particular integral is difficult to find. That means the method of variation of, or this method in solving a differential equation, is used when the complementary function, when the CF is known or easy to find, and the particular integral is difficult to find, by other methods. Okay, we have formulas or methods for sin AX, cos AX, not for cosec AX, sec AX, tan AX. So it is a method when we know the complementary function. We can find a particular integral by taking by using this method. Okay, for this method we can consider, let us consider the second order linear differential equation. D square y by dx square plus p into dy by dx plus q into y is equal to r, where p comma q comma r are functions of x, are constants, or sometimes they are constants. For this differential equation, we have to take the general solution as, let the solution is y equal to yc plus yp. We have to take the general solution is y is equal to yc plus yp. Okay. Now, where yc is the complementary function, complementary function, and yp is the particular integral. Now we can take the yc as or let yc is equal to some c1 into u plus c2 into v. Okay, by solving the corresponding auxiliary equation, will get a complementary function that is in the form of c1u plus c2v. Okay, where u and v are the corresponding functions of the differential equations, and we have to take a letter yp is equal to au plus bv, where capital A and capital B are parameters, and are given by two formulas. For A, we have one formula. For B, parameters are they are functions of Excel also. So here we have A, capital A is equal to formula minus integral minus VR by 2 V dash minus V U dash into dx. This is formula for A. And B is equal to formula integral UR divided by U V dash minus V U dash into dx. This is the formula to find the V value. This is dx. Okay. Now, how to solve the differential equation in variation of parameters. First, the given differential equation should be in second degree, and first we have to find complementary function, that is YC, that is in the form of C1U plus C2V, and we have to take YP as AU plus BV. Okay, we should take, and where A and B are parameters, they are given by these two formulas. Okay, we could job present textbook lo different method ఉంటుంది, అలాగే pricing అని కూడా different method ఉంటుంది. You can use these two formulas to find AU and BV. Okay, A is nothing, A is not constant, it is sometimes it is a function of X also. Okay, now I am taking one problem, taking simple problem. Just it is from DL. The particular integral of y double dash here I have to see here dy by dx plus p into dy by t square y by dx square plus p into dy by dx plus q into y is equal to r low, where p and p q r are functions of x are sometimes constants, and it is a function of x, right side value. Okay, now I am taking problem here. The particular integral of y double dash plus y is equal to secant x. Okay, YC వరకు same procedure and there is no change in YC. First we have to consider the auxiliary equation, that is m square plus 1 is equal to 0. That is m is equal to plus or minus. So the complementary function YC is equal to C1 cos x plus C2 sin x. Now this is nothing but U and V. This is nothing but V. Okay, when we have U and V, first we have to find U V dash minus V U dash value. That is U into U means here it is cos x, V dash means sin x derivative, that is also cos x, minus V means sin x, and U dash means cos x derivative minus sin x. This is nothing but cos square x plus sin square x. Cos square x plus sin square x, that is equal to 1. This is the value of U V dash plus V U dash. Now we have to find the parameters, means capital A value. Capital A is equal to formula minus VR by UV dash plus minus VU dash. So here minus V is equal to sin x. R is the right side value, that is secant x. This is secant x. Denominator is 1, dx as this. This is equal to integral sin x, secant x can be written as by cos x. Okay, 1 by cos x. This is equal to integration of sin x by cos x, that is integration of tan x. I am writing. Now this is equal to minus log tan x integration secant x. So we can write this as log secant x power minus 1, that is nothing but log 1 by secant x, that is cos x. This is the a value. Now what the particular integral is in the form of au plus dv. So we have a value, this is right here. So find au. U value is cos x and multiply with a. So we get cos x into cos x u into a, that is log cos x. This is au value. Next we have to find b. Similarly, b is equal to formula integral ur by ub dash minus vu dash into dx. So b is equal to sin x. Sorry, b is equal to, what is the formula here? U means here cos x, r means secant x, ub dash minus vu dash value is 1. This is equal to cos x, sin x will be cancelled, integral dx, that is equal to x. Therefore bv is equal to, b means x, b means sin x. So this is equal to x into sin x. Now add au plus bv, that gives the particular integral yp is equal to cos x into log cos x plus x into sin x. This is the particular solution of the particular integral of the given differential equation. Okay. Now I am taking another problem. This previous problem is from DL. Okay. I am taking another problem from set. It is from set. By using the method of variation of parameters. By using the method of variation of parameters. The particular integral of the differential yp, particular integral yp of the differential equation d square y by dx square plus 9 into y is equal to cosec 3x. Cosec 3x can be expressed as yp is equal to ax into cos 3x, plus bx into sin 3x, ax into cos 3x plus bx into sin 3x, where a of x and b of x are given. We have to find a of x and b of x. Now already we are given yp is equal to a x into cos 3x plus b x into sin 3x. This is nothing but u. This is nothing but b. So first I am finding uv dash minus vu dash value. That is cos 3x into v dash. That is 3 cos 3x minus v sin 3x into cos 3x differentiation minus 3 sin 3x. So this is equal to, we can take 3 common, cos square 3x plus sin square 3x. This is nothing but 3. Okay. Now we need to find A of x and B of x. Same formulas you can use. Now, A of x is equal to integral minus VR. V equal to sine 3x. R is equal to outside term, right side term, cosec 3x divided by 3 into dx. Now this is equal to sine and cosec will be cancelled. This is equal to minus dx by 3, that is nothing but x by 3. So B of x value. Similarly, B of x is equal to formula integration of UR. U equal to cos 3x, R equal to cosec 3x. Denominator 3 as this 3x. This is equal to 1 by 3 integration cos 3x divided by cosec 3x goes to denominator. So it becomes sin 3x into dx. This is equal to 1 by 3 integration of cot 3x dx. This is equal to 1 by 3 integration of cot 3x is log sin 3x whole divided by 3. This is nothing but 1 by 9 log sin 3x. This is the P of x value. P of x value వచ్చేసింది. Next P of x value. This is a set question. Okay. Now I am taking another problem. From DL. This is a DL question. The complementary function or simply complementary function. We are not asking the particular integral, just we are asking A of x and B of x values only. Okay. So I am taking one question from DL. Yeah. Complementary function. Complementary function of the differential equation d square plus a square into y. D square plus a square into y is equal to cosec 3x is. Just we are finding, sorry, it is not cosec 3x. It is sec ax. This is sec ax is. Just we have to find a complementary function. Complementary function को method of variation of parameter అవసరం. ఇక్కడ క్వశ్చన్ లో ఏమడిగాడంటే by the method of variation of parameter. Variation of parameters. ఏ మెథడ్ లో చేసినా మనకు కాంప్లిమెంటరీ ఫంక్షన్ సేమ్ అదే. ఫస్ట్ ఐఎమ్ టేకింగ్ ది auxiliary equation, that is m square plus a square is equal to 0, that is m is equal to plus or minus ai. M is equal to plus or minus ai are the complex roots. So yc complementary function yc is equal to c1 cos x cos ax plus c2 sin ax. Okay, this is the complementary function. Now I am taking another problem. It is also from DL. Applying the method of variation of parameters. The method of variation of parameters. The complementary function. complementary function for the equation dqy by dx cube plus dy by dx is equal to sec x is. Okay, again complementary function అడిగాడండి కాబట్టి instead of variation of parameters use చేయాల్సిన అవసరం లేదు. Direct we can write the auxiliary equation, that is mq plus m is equal to 0. We can take m as common, m square plus 1 is equal to 0. So m is equal to 0 comma plus or minus I are the roots. So here 0 is the real root, plus or minus I is the imaginary roots. So yc complementary function is equal to c1 e power 0, that is c1 plus c2 cos x plus c3 sin x. Just ఇక్కడ కన్ఫ్యూజ్ చేయడానికి ప్రాబ్లమ్ ను మన టైం ను వేస్ట్ చేయడానికి ఇక్కడ క్వశ్చన్ లెందీగా ఇలా అడుగుతున్నాడండి. కాంప్లిమెంటరీ ఫంక్షన్ ఏ మెథడ్ లో చేసినా సేమ్ అదే వస్తుందండి. దేర్ ఇస్ నో సెపరేట్ మెథడ్ టు ఫైండ్ ద కాంప్లిమెంటరీ ఫంక్షన్. Now I am taking another problem from Polytechnic lecturers, and also it is from JL. The general solution of d square minus 2d plus 2 into y is equal to e power x into tan x is. గుర్తుపెట్టుకోండి, tan x, sec x, cosec x అండ్ cot x ఈ టర్మ్స్ ఉన్నప్పుడు ప్రాబ్లమ్ ను ఖచ్చితంగా మనం వేరియేషన్ ఆఫ్ పారామీటర్స్ లోనే చేయాలి. ఓకే, నౌ ఫస్ట్ ఐ యామ్ టేకింగ్ ద corresponding auxiliary equation, that is m square minus 2m plus 2 is equal to 0. So here m is equal to plus 2 plus or minus and root of b square minus 4ac 1 into 2 divided by 2 into 1, that is equal to 2 plus or minus, this is 4, this is minus 8 root 2 minus 4, that is 2i divided by 2, that is equal to 1 plus or minus. So the complementary function yc is equal to e to the power of x into c1 cos x plus c2 sin x. So here u is equal to, we can multiply with the e power x now. So c1 e power x into cos x first term plus c2 e power x into sin x second term. So this complete value is u, and this complete value e power x into sin x value is v. So we have to find ub dash and vu dash. Ub dash minus vu dash. U, that is e power x into cos x. V dash means differentiation of this with respect to x by UV method. So e power x into cos x plus e power x into sin x. Okay, minus v into v is equal to again e power x into sin x, and u dash, here the differentiation of this, it is minus e power x into sin x plus e power x into 6. Just I am differentiating by using UV method. So here e power 2x cos square x first term plus e power 2x cos x into sin x, here minus half minus plus e power 2x into sin square x minus e power 2x into sin x cos x. this term will be cancelled. So we can take e power 2x as common. So e power 2x of remaining cos square x plus sin square x become 1. That is e power 2x. This is the value of q v dash minus vu dash. Now we have to find capital A value. Capital A is equal to minus VR. V equal to e power x into sin x, second term. R is equal to outside term is e power x into tan x, right side term. Now uv dash plus uv dash minus vu dash value is e power 2x. We have found it. That is dx e power x, e power x, e power 2x will be cancelled. So this is nothing but integration minus integration. Tan x is sin x by cos x. We have one more sin x in the numerator. That becomes sin square x by cos x into dx is equal to sin square x can be written as 1 minus cos square x. Denominator is cos x as. So we can write this as integration of 1 by cos x become secant x cos square x by cos x. So that is cos x only into dx. Now this is equal to minus integration of sec x. Integration of sec x is log sec x plus tan x minus integration of cos x, that is sin x. So this is equal to minus log secant x plus tan x plus cos x. This is the value of A. Now we have to find B value, sorry, AU. So first I am taking A, therefore AU is equal to, as we know that U value is e power x into cos x, and this is minus log secant x plus tan x plus cos x. Okay, this is the AU value. Now we have to find BV.
Sir, it is sin x, sir, not cos x.
No, okay, it is sin x. No. Yes, sin x. So it is also sin x. Now we are finding B value. That formula is integration of UR. U equal to e power x into cos x and R is equal to e power x into tan x. Denominator is e power 2x dx. And e power 2x will be cancelled. Cos by cos x into sin by cos. Cos will be cancelled. That is integration of sin x. Integration of sin x dx. That is equal to minus cos x. So we can find dv value. V is equal to we have e power x into sin x. So we get a minus e power x into sin x into cos x. This is dv value. Now we have to find yp. Yp is equal to formula. Yp is equal to au plus bv. While adding au and bv, this term and this term is same. Okay, sin x cos x e power x minus sin x cos x e power x. So these two terms are cancelled. So remaining minus e power x into cos x into log secant x plus tan x. This is the particular integral. Okay. Now the general solution is y is equal to, you can write yc plus yp is the general solution. Now I am taking another problem. Yes. Your voice is break. Yes, madam. Your voice is break. Now I'm taking another problem from settle, and also it is from jail. Same question jail lo adigadu, settle lo adigadu. Okay. The solution of d square y by dx square plus y is equal to cosec x by variation of parameters. Okay. Is we are given options. I am taking options. With the help of options, we can conclude the solution. Easy. First, I'm writing the set options. Okay. That is sin x plus x into log modulus of cos x. And option B, minus x into cos x plus sin log of modulus of sin x. And option C, x sin x minus cos log modulus of sin x. And option D, x sin x plus cos x log secant x. Okay, these are the options here. Now I am taking first finding the complementary function. Okay, the corresponding auxiliary equation m square plus 1 is equal to 0, m is equal to plus or minus I. So yc is equal to c1 cos x plus c2 sin x. This is the complementary function. Now it is u and this is v. So u v dash minus v u dash value cos x into cos x minus sin x into minus sin x. This is equal to cos square x plus sin square x. This value is 1. So we can find the a value, that is a is equal to integral minus v equal to sin x, r is equal to right side value cosec x, denominator is 1, so dx. Here cosec x, sin x will be cancelled, so we can write minus x integration of dx. So we can write the au value, u is equal to cos x, so minus x cos x. ఇక్కడ ఆప్షన్ చూసుకోండి, ఇక్కడ మైనస్ ఎక్స్ కాస్ ఎక్స్ తోటి ఎన్ని ఆప్షన్స్ ఉన్నాయి? ఓన్లీ వన్ ఆప్షన్, ఒకటే ఆప్షన్ ఉంది కాబట్టి ఓకే, we can easily identify the option. ఓకే, ఒకవేళ ఎక్స్ మైనస్ ఎక్స్ కాస్ ఎక్స్ తోటి ఇంకో ఆప్షన్ కూడా ఉందనుకోండి, we have to find the b of x also. Okay, I'm not finding b of x. Okay, no need to find b of x. So I'm taking another problem from DL. The solution of d square plus a square into y is equal to tan ax by variation of parameters method. Variation of parameters method. Okay. Is I am taking options. First option, y is equal to C1 cos AX plus C2 sin AX minus 1 by A square log secant AX plus tan AX. And second option, y is equal to C1 cos H AX plus C2 sin H AX plus 1 by A square log secant AX minus tan AX. And third option, y is equal to C1 cos A square X plus C2 sin A square X plus 1 by A square log secant AX plus tan AX. And the last option, y equal to C1 cos AX plus C2 sin AX plus 1 by A square log secant AX plus tan AX. Okay. Now I'm seeing the options here. The roots of the quadratic equation. Here, auxiliary equation is m square plus a square equal to 0. So m is equal to plus or minus a. When m is equal to plus or minus a, then the complementary function yc c1 cos ax plus c2 sin ax. Okay. ఇక్కడ ఆప్షన్లలో సెకండ్ అండ్ థర్డ్ ఆప్షన్లో లేవండి, కాబట్టి రెండు కాదు, రెండిట్లో ఏదైనా ఒకటి అవుతుంది. నౌ వి కెన్ టేక్ u value. This is u and this is v. uv dash minus vu dash cos ax into v dash a sin ax minus a sin ax into minus a sin ax. This is nothing but a of cos square ax plus sin square ax. This is equal to a1. This is the value of u v dash minus vu dash. Now we can find au and bu value. First I am taking a value, that is equal to integral minus vr. V equal to sin ax. R is nothing but tan ax. Denominator is a ax. This is equal to minus 1 by a. Integration of this is sin square ax. Tan means sin by cos, sin into sin square by cos ax dx.
Sir, v dash
Yes,
v dash a cos ax kada sir.
v dash I am taking v value minus v. V value is sin ax and r value is tan ax. Okay, is it okay? Minus 1 by a.
పైన స్టెప్ సార్ మేడం చెప్పింది
V dash is equal to sir u v dash minus v u dash.
U dash u is cos ax. Okay, v dash is a cos
Cos
ax.
ax.
Okay. I'm sorry. This is okay. Okay, it's okay. Now this is we can write 1 minus cos square ax. Denominator is cos ax as this dx.
Cos 2x, sir,
Yeah,
not cos square ax.
Sin square ax can be written
Yes,
as
sir. Sin square ax is equals to 1 minus cos 2ax.
cos 2ax.
Yes, sir. Not square.
Okay, we have sin square theta plus cos square equal to 1. From this we can write sin square theta minus secant ax integration log secant ax plus tan ax, denominator is a, and cos ax integration sin ax by a. So we can write this as minus 1 by a square of log secant ax plus tan ax minus sin ax. And this is the value of a. Now we have to find AU. Therefore, AU is equal to minus 1 by a square. U is equal to cos ax. So cos ax of same term log secant ax plus tan ax minus sin ax. Okay, this is the AU value. Next we go for BV. So similarly, B is equal to formula UR. U is equal to cos ax and V is R equal to tan ax. UV dash minus VU dash is equal to A. This is nothing but 1 by A integration of cos, tan is sin by cos, cos will be cancelled, sin ax.
Excuse me, sir. How we are writing B, sir?
Yeah. V value. U is equal to, we have, this is U value. Cos ax value is U and V value is sin ax. We are taking yc equal to C1U plus C2V. We are comparing this equation with the C1U plus C2V. So U equal to cos ax and V equal to sin ax. Now, this is equal to integration of sin ax. That is minus 1 by, this is nothing but cos ax by A and A is A square. This is the B value. So we can multiply with the B. So BV is equal to minus 1 by A square AU plus BV. B equal to, we have sin ax. Sin ax into already cos ax is there. This is the BV value. Now while adding YP means AU plus BV. While adding these two, you can see here minus of 1 by A square cos ax minus sin ax, minus minus plus this term and this minus term will be cancelled. Remaining minus 1 by A square cos ax log of secant ax plus tan ax. This is the
Option A is correct, sir.
okay. So
Option A is correct.
option 1 is the correct option. Okay. Now I'm taking yes.
Option 1 లో
One is the mistake, sir.
Sir,
Cos
cos
ax.
ax లేదు కదా సార్ ఆప్షన్ లో
Cos
ax
cos ax
yp సార్ yp ఇంటిగ్రల్
YP లో cos ax. ఓకే,
అక్కడ లేదు సార్ ఆప్షన్ 1 లో.
ఇక్కడ cos ax ఉండాలండి ఖచ్చితంగా.
1 by a square cos ax should be there.
Cos ax should be there. Okay, compulsory ఉండాలి. Now I'm taking another problem. Just ఏ ప్లేస్ లో 1 తీసుకున్నాడండి. 1 తీసుకొని ప్రాబ్లం చేశాడు. ఓకే, you can do this problem. Just taking equal to 1. By using, it is from J, by using the method of variation of parameters. Variation of parameters. There is a particular integral. The particular integral of d square y by dx square plus y is equal to tan x. Okay, try చేయండి. Simple, just in place of a we are given 100. Okay, now I am taking another problem. You can do this problem also very easy. A equal to 1. Just I'm taking one more problem. I'm giving one more problem. The complementary function. Okay, this is simple. The complementary function of d square plus 4 into y. This is y is equal to tan 2x by the method of variation of parameters. The method of variation of parameters. You can do this problem. Easy, we can find that. Here m is equal to plus or minus 2y. That is c1 cos 2x plus c2 sin 2x is the corresponding complementary function. Now I am taking one more problem from set. It is also from J. Okay, a particular solution. No need to take a equal to 2. Just we find complementary function. మనకు general solution find out చేయమన్నాను. Okay, I'm taking another problem. A particular solution of d square y by dx square plus 2 into dy by dx plus y is equal to e to the power of minus x into log x to the base e is. Okay. This is a question from set and J. First, I am taking the auxiliary equation m square plus 2m plus 1 is equal to 0. That is nothing but m plus 1 whole square equal to 0. That is m is equal to minus 1 comma minus 1. So the complementary function yc is c1 plus c2 x into e to the power of minus x. This can be written as c1 e power minus x plus c2 x into e power minus x. So it is in the form of c1u plus c2v. This is v and this is u. So find the u v dash minus vu dash value. That is equal to u is e power minus x. V dash means integration differentiation by UV method. Yeah. So minus x into e power minus x plus e to the power of minus x minus v. V is x into e power minus x u. That is minus e power minus x. This is nothing but minus x e power minus 2x plus e power minus 2x plus x into e power minus 2x. This is equal to e power minus 2x. These two terms are cancelled. So now we can find capital A value and capital B value. So capital A is equal to integration minus VR. B is equal to, we have x into e power minus x. R is equal to e power minus x into log x. E power minus x into log x. Denominator is e power minus 2x dx. Here e power minus 2x, e power minus 2x will be cancelled. So minus integration of x into log x. Now integration by parts. Here u equal to log x. Integration of v means x square by 2 minus integration of v x square by 2 log x integrate differentiation 1 by x dx. So this is nothing but x square by 2 log x minus here 1x will be cancelled. Integration of x is x square by 2. Already 2 is there, x square by 4. This is the value of A. Now we have to find the AU value. Therefore, AU. U equal to what we have e power minus x. So x square by 2 into e power minus x log x minus x square e power minus x by 1. This is the B
Sir,
value.
minus రాయలేదు మీరు.
Okay, here it is minus. Okay,
Minus
sorry.
x log x is there. na, sir.
Yeah, yes. This is minus. So we have this is minus and this is plus. Okay, this is AU value. Similarly, we can write finding B value. B is equal to formula UR. Here U is equal to e power minus x. R is equal to e power minus x into log x. Okay, e power minus x into log x. Denominator is e power minus 2x into dx. E power minus 2x, e power minus 2x will be cancelled. This is integration of log x. Integration of log x formula, direct I am writing x log x minus x. Now we can multiply b with b. So bv is equal to e power sorry, what is b? X e power minus x. So while multiplying, we get x e power minus x square e power minus x into log x minus x square e power minus x. This is bv. Now we have to find the particular integral, that is yp equal to au plus bv. So this is equal to, we are adding these two only. So we can take the first term. This is one term. This is minus 1 by 2. Nothing but 1 by 2. That is x square by 2 e power minus x log x. Here 1 by 4. I am taking here minus 1 by 2 plus 1 only is equal to 1 by 2. Next 1 by 4, here 1, that is equal to minus 3 by 4. This is 3 by 4 x square e power minus 6. Okay, this is the particular solution of the given differential equation. Okay, this is a set and problem. We can do one problem. Same like this. The particular integral of y double dash minus 2y dash plus y is equal to e power x into log x. Please. Okay, you can do this problem. Your difference is previous problem lo first plus undante ikkademo minus undi. Deeniki difference entante ikkada minus untundi, ikkada plus undi. You can do this problem. Now I am taking one more problem from set. The particular integral of the equation d square y by dx square plus y is equal to secant square x is. Secant undi ante we go for variation of parameter, or cosecant unna, tan unna, cot unna, we go for variation of parameters. First I am taking the auxiliary equation, that is m square plus 1 equal to 0, m is plus or minus I. So the corresponding complementary function c1 cos x plus c2 sin x. Now this is u and this is v. So uv dash minus vu dash is equal to cos x into cos x. Cos square x minus sin x into minus sin x. That is nothing but plus sin square x is equal to. Now we go for a value. A is equal to formula minus VR. That is sin x into r. R is secant square x. Denominator is dx. So this can be written as minus integration sin x into cos secant square x can be written as 1 by cos square x. That is first time writing secant x first term, and the sin x by cos x, nothing but tan x dx. Now integration of secant x tan x is nothing but minus will be minus first. Integration of secant x into tan x is secant x. So this is the value of A. Therefore, u is equal to cos x, b equal to minus a equal to minus secant x, u equal to cos x. So minus secant x into cos x, that is equal to minus 1. AU value is minus. Similarly, we can find the B value. B is equal to UR. U equal to cos x. B equal to secant square x. R equal to secant square x. Denominator is 1. This is equal to integration of 1 cos secant will be cancelled, secant x. Now, integration of secant x is log secant x plus tan x. Now apply multiply with b. So bv is equal to v equal to what? Sin x. So sin x into log secant x plus tan x. This is dv value and this is au value. Therefore, the particular integral yp is equal to au plus bv. Au plus bv, that is equal to sin x, first I am writing bv value, log secant x plus tan x minus au value is minus 1. Okay, plus minus 1, that is minus. Okay, these are the problems related to variation of parameters. All problems of previous questions I have covered. If you have any question, you can ask. Yes.